Hi there, I'm Machine Pun Kelly, and today I want to talk about climate change. Why it's not some far-off threat, but a crisis already here, and what happens by the year 2100 if we don't act. You might not know it, but with carbon dioxide at 426 parts per million and warming up 2.3 to 2.7 degrees Fahrenheit, the only question is how bad it gets. Let's break it down the physics, from human causes to tipping points that could wreck civilization. The first thing you need to know is climate change isn't waiting, it's hitting us now. Global temperatures are up 2.3 to 2.7 degrees Fahrenheit since pre-industrial times. In 2024, we hit 2.63 degrees Fahrenheit above pre-industrial, the hottest year ever. Summer nights are warmer, up 1.1 to 1.4 degrees Fahrenheit since 2000, making it harder to cool off. Storms are fiercer. Hurricanes deliver 10 to 15% more rain. Floods are up 20% in places like the US. Arctic ice is down 10%, and sea levels have risen 4 inches since 1993, flooding coasts. Carbon dioxide, or CO2, at 426 parts per million in 2025, up from 280 in 1850, traps heat, adding 2 watts per square meter of radiative forcing. Methane's up 150% to 1900 parts per billion, adding 0.5 watts per square meter. These gases are driving wild weather now, 10% stronger winds and storms, 5 to 10% less snow in places like Minnesota. 2024 had record heat waves and floods, not future risks. If we don't cut emissions, 36 gigatons of CO2 yearly, we're on track for 5.4 to 9 degrees Fahrenheit warming by 2100. That flips 9 tipping points from monsoon shifts to ice sheet collapse, wrecking food, cities, and nations. It's basic physics. More greenhouse gases, more heat, worse chaos. The question isn't if, it's how bad. Naysayers claim warming is natural, like the Eemian interglacial 125,000 years ago, but the physics says otherwise. There is something called the Milankovitch cycles. That's how the Earth's orbit changes from year to year. Some years it's rounder, and some it's more elliptical. When it's elliptical, it gets closer to the Sun. We call that orbital eccentricity. Back then, it was high orbital eccentricity 0.04 versus today's 0.0167. That meant the Earth was getting closer to the Sun, which warmed it. The Earth also doesn't always have the same tilt to its axis. Back then, a 23.5-degree axial tilt boosted northern hemisphere sunlight by 30 watts per square meter, warming Earth 1.8 to 3.6 degrees Fahrenheit. This drove CO2 to 300 parts per million via ocean outgassing and soil release. It took 5,000 to 10,000 years, a slow, natural cycle. Today, we're in a low eccentricity orbit, 0.0167, adding less than 0.1 watts per square meter per IPCC AR6. Warming of 2.3 to 2.7 degrees Fahrenheit since 1900 is too fast for Milankovitch cycles, which operate over tens of thousands of years. CO2 jumped from 280 to 426 parts per million, and greenhouse gases, carbon dioxide, CO2, methane, CH4, nitrous oxide, N2O, and chlorofluorocarbons, CFCs, trap heat, driving warming. CO2, from burning coal, oil, and gas, rose 52% from 280 to 426 parts per million, 1850 to 2025, adding 2 watts per square meter. Methane from agriculture and landfills soared 150% from 700 to 1900 parts per billion, adding 0.5 watts per square meter per IPCC AR6. Nitrous oxide from fertilizers climbed 20% from 270 to 335 parts per billion, contributing 0.2 watts per square meter. CFCs from old aerosol cans peaked at 250 parts per billion, but dropped 20% after bans, adding 0.1 watts per square meter per NOAA. These levels are the highest in 3 million years since the Pliocene, when CO2 hit 300 to 400 parts per million. Back then, natural cycles drove CO2. Now, human emissions, 36 gigatons CO2 yearly, dominate, with deforestation 0.5 parts per million per year, and cement 0.2 parts per million per year, adding more. This traps heat, boosting water vapor and storms. To understand what drives climate change, first we have to talk about gradients. A gradient is defined as an increase or decrease in the magnitude of a property, such as temperature, pressure, or concentration, observed in passing from one point or moment to another. Climate change involves all three of these, with salinity gradients being the concentration gradient. Let's talk about each of them. We'll start with temperature gradients. Picture holding your hand to a cold window on a winter day. The chill you feel is a temperature gradient, the difference between warm indoors and cold outside, driving heat flow. In climate, temperature gradients, like 90 degrees Fahrenheit from equator to Arctic over 10,000 kilometers, move air and water, creating winds, 5 to 10 meters per second, and currents, per NOAA. These gradients shape weather. Trade winds bring rain. Jet streams steer storms. Arctic warming at 5.4 degrees Fahrenheit outpaces tropics warming at 2.3 to 2.7 degrees, shrinking the gradient, or the difference between those temperatures. This slows winds like trade winds by 5 to 10% and shifts storm tracks south, increasing rain 10 to 15%. Warmer nights, 1.1 to 1.4 degrees Fahrenheit, reduce cooling, further disrupting gradients. Moving on to pressure gradients. Think of a pressure cooker's release valve. High pressure inside rushes to low pressure outside, like air moving in the atmosphere. Pressure gradients, like 1015 to 1005 hectopascals, the measurement for pressure, over 1,000 kilometers, drive winds such as ITCZs 5 to 10 meters per second, shaping rain and storms. Warming of 2.3 to 2.7 degrees Fahrenheit and water vapor at 7% more per 1.8 degrees Fahrenheit intensify low-pressure systems by 1 to 2 hectopascals. This shifts winds like monsoons 1 degree north, boosting rain 10 to 15% in some areas while drying others by 10%. Ocean warming of 1.8 to 3.6 degrees Fahrenheit also strengthens storms. Salinity gradients, like 35 to 0 practical salinity units in the North Atlantic, drive ocean currents. Warming melts 4,700 billion tons of Greenland ice, lowering salinity by a climate pattern refers to the long-term prevailing weather conditions in a specific region. There are a number of climate patterns that are affected by climate change. Intertropical Convergence Zone, ITCZ, a low-pressure band near the equator where trade winds meet, driving tropical rain, per NOAA. Warming shrinks gradients, shifting ITCZ 1 degree north, reducing rain 10% in the Sahel. El Niño Southern Oscillation, ENSO, a Pacific cycle of warm El Niño and cool La Niña, driving global weather, per NOAA. Warming intensifies El Niño 10%, cutting Atlantic hurricanes 20 to 30%, boosting Pacific ones 10 to 20%. Polar vortex, stratospheric winds 100 to 200 miles per hour, trapping Arctic cold. Arctic warming, 5.4 degrees slows it 10 to 15%, shifting storms 1 to 2 degrees south. Thermohaline circulation, AMOC, Ocean currents driven by salinity, warming Europe, per NOA. Ice melt slows AMOC 10 to 15%, shifting rain 10%. Jet streams, high-altitude winds, 100 to 200 miles per hour steering storms, per NOAA. Warming slows them 10 to 15%, shifting track south, stalling storms 5 to 10 days. Westerlies, mid-latitude winds 5 to 15 meters per second, guiding storms. Warming slows them 5 to 10%, altering rain patterns. Polar easterlies, high-latitude winds 5 to 10 meters per second, trapping cold air. Warming slows them 10 to 15%, increasing cold outbreaks 5 to 10%. Monsoon winds, seasonal winds 5 to 10 meters per second, bringing rain, per NOAA. Warming shifts them 1 degree north, altering rain 10 to 15%. Trade winds, tropical winds 5 to 10 meters per second, driving rain, per NOAA. Warming slows them 5 to 10%, shifting rain belts. Nighttime temperatures, summer lows cooling 10 to 20 Fahrenheit below highs. Warming raises nights 1.1 to 1.4 Fahrenheit, boosting storm intensity 10 to 15%. Hurricane activity. Storms driven by warm oceans, greater than 79 degrees Fahrenheit, per NOA. Warming increases intensity 3 to 10%, rainfall 10 to 15%. Rainfall patterns, driven by pressure gradients, delivering 10 to 20 inches. Warming boosts heavy rain 10 to 15%, shifts belts. Storm tracks, paths guided by jet streams. Warming shifts them 1 to 2 degrees south, stalling storms. Cold air outbreaks, Arctic air surges south, per NOAA. Warming increases outbreaks 5 to 10%. Diurnal temperature range, day-night temperature gap, 10 to 20 degree Fahrenheit. Warming shrinks it 1.8 degree Fahrenheit, altering winds 5 to 10%. And there are feedback loops, which amplify or reduce warming. Positive feedbacks dominate, making things worse, per IPCC AR6. Water vapor increases 7% per 1.8 degrees Fahrenheit, adding 0.1 watts per square meter, boosting warming 0.09 to 0.18 degrees Fahrenheit, per NOAA. Ice albedo feedback from 10% Arctic ice loss absorbs 0.1 watts per square meter, adding 0.09 degrees Fahrenheit. Soil respiration releases 0.1 parts per million CO2 yearly, and permafrost thaw adds 0.1 to 0.2 parts per million methane, amplifying warming 0.18 degrees Fahrenheit, per Schur et al., 2015. Cloud feedback can cool. Low clouds reflect 0.1 watts per square meter, but often warms. High clouds trap heat, per NOAA. These loops shift gradients, intensifying storms and rain, pushing toward tipping points. Tipping points are thresholds where systems flip irreversibly, per Lenton et al. 2019. One falling can trigger others. Monsoon shift shifts rain 1 degree north, cutting 70% of South Asia's rainfall, starving crops. AMOC slowdown, 50 to 100% slowdown, cools Europe 5 to 10 degrees Fahrenheit, shifts rain 10%. Weyes collapse, raises sea level 16 feet, flooding coasts. Amazon dieback, releases 50 gigatons of carbon, warming 0.5 degrees Fahrenheit. Greenland melt, adds 23 feet to sea levels. Permafrost thaw, releases 0.2 ppm methane, warming 0.2 Fahrenheit. Coral reef die-off, 90% loss disrupts fisheries. Boreal forest dieback, releases 20 gigatons carbon. Arctic sea ice loss, 100% summer loss, adds 0.1 watts per square meter, per NOA. Monsoon shifts dry crops, pushing AMOC slowdown. Ice melt floods, driving Amazon dieback, cascading chaos. What happens if we don't act? By 2100, if CO2 hits 670 to 970 parts per million, warming 5.4 to 9 degrees Fahrenheit, all tipping points flip. Wet bulb temperatures above 95 degrees Fahrenheit make South Asia, India, the Persian Gulf, India, Dubai, and the Sahel uninhabitable, displacing 1 billion people. Sea level rise of 39 feet submerges islands such as Maldives, Kiribati, Bahamas, and cities like Miami, Dhaka, and Shanghai, abandoning 40% of coastal populations. Hurricane intensity rises 3 to 10%, with 10 to 15% more rain. Food production drops 20 to 30%. Up to 100 million die from famine, heat, and conflict. Geopolitical wars over water and 1 billion displaced destabilize nations like Somalia. Stable nations, such as the U.S., face unrest absorbing refugees. CO2 at 970 parts per million ensures warming continues past 2100. This is our future without action. It's basic physics. CO2 drives catastrophe. Act now by staying informed and spreading the word. Once again, I'm Machine Pun Kelly, and thanks for watching.